Hi, Math 055 students. So today we are doing rational expressions and we're dividing and simplifying. So let's go ahead and look at your first example. So your first example is a fraction with 16 in the numerator and y squared in the denominator. Okay, so to rationalize this, we always first see if we can divide, but of course 16 divided by y squared isn't going to change anything. And so the second thing would be just looking to see if you have square roots, which 16 is a perfect square, so the square root of 16 is 4, and the square root of y squared is y. So our answer would just be 4 over y. Okay? All right, so let's try doing another one. So the second one that we have for an example is 27 over 8, and it's a cubed root. I bet by now you're recognizing that 27 is a perfect cube as well as 8. So the cube of 27 is 3, and the cubed root of 8 is 2. So we have simplified the rational expression. All right, so let's go ahead and look at number 3. So number 3 is 50x to the 6th divided by y to the 10th, and it's a square. Okay, so nothing to divide, but 50, if we factored it, we would have a perfect square because 25 times 2 is 50 and 25 is a perfect square. X to the 6th is also a perfect square because it's an even number, and y to the 10th is also a perfect square. Okay, so I'm going to put my answer over here, so I don't want to confuse you. It's just I have space here. The square root of 25 is 5. The square root of x to the 6th, so we would just divide. 6 divided by 2 is 3, so that's x cubed. And then y to the 10th is also a perfect square. 10 divided by 2 is 5, so it would be y to the 5th. So the only thing we have left inside the radical is the 2, so we would put that back inside the radical. I'm going to erase this. And you are done. Okay, let's look at the next example. So let's see. Our next example is 32 divided by 2, and they're both square roots. Okay, so 32 and 2 are not perfect squares, but I can divide. So 32 divided by 2 would give me 16. 16 is a perfect square root because 4 times 4 is 16. So my answer would just be 4. Okay, so let's look at example 4. In example 4, we have a 6 outside of the radical sign. And then we have cubed roots of 54 divided by 2. Okay, so we would begin by dividing 54 by 2, which gives us 27. "27 is a perfect cube. Remember, 3 times 3 times 3 is 27. So that would equal 3. We have this 6 outside of the radical sign, so we multiply the 6 times 3. So our complete answer then is 18. Okay, we're all ready for example 5. So example 5 is a root 4, and we have 32x to the 6th, y to the 5th, and that's over x with a negative 2 exponent and y squared. Okay, so first of all, we go ahead and divide what we can divide. We can't divide the 32, so we're still going to have it in, I'm going to write it there. So when you divide these, remember we're subtracting. So it becomes 6 take away a negative 2. 6 take away a negative 2. So that actually would be an 8. So we have x to the 8th. 5 take away 2 is 3, so we would have y to the 3rd. And that's all going to be under a radical sign, and it's root 4. Okay, I'll just erase that part. Okay, so is 32 a perfect root 4? Well, let's think about it. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it doesn't work for the 2's, but what if we factor it so that we had 16 times 2? So 16 would be a perfect root 4. X to the 8th would also be a perfect root 4. So let's pull that out. So the root 4 of 16 is 2. So it is now gone. The root 4 of x to the 8th, we just divide. 8 divided by 4 is 2, so we get x squared. And then y third is not a perfect root 4. So inside our radical sign then, we still have the 2, and we have y cubed. So 2y cubed. Wink. So our final answer then will be 2x squared, and then root 4, and inside the radical we have 2y cubed. All right, the next ones are the eutriots. And I really doubt that you're going to have too much trouble with 1 or 2 or 3. 4 might give you a little bit of trouble, but let's look at number 5 together, because that's probably the hardest one. So number 5 is a root 5, and we have 64 x to the 9th, y to the 8th, over x with a negative 1 exponent and y with a 2. Okay, so clue here is it's x to the 5th. So if we were to go ahead and divide, we could get rid of that denominator. So let's do that first. Make this a little bit shorter. So 9 take away a negative 1 is going to give me x to the 10th. 8 take away 2 gives me y to the 6th. Then the 64, if we were to break this up and factor it, we might be able to find a 5th root. So I am thinking that 32 times 2 gives me 64, and I'm pretty sure that 32 is a perfect 5 root, because 2 times 2 times 2 times 2 times 2, I think, is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2 is 32. And so we'll put 32 times 2 in there. It's a little bit crowded. And we've gotten rid of the denominator, so we don't need the denominator part. All right, but we're not finished yet, because now we need to pull out all of the root 5s. So we just figured out that 32 root 5 would be a 2. So we'll pull that out in front of the radical sign. The 2 is not a perfect root 5, so we can't do anything with it. X to the 10th would be a perfect root 5, so we would just divide 10 divided by 5, which is 2, which means that's going to be x squared. Y to the 6th is also a perfect root 5. Well, it's not exactly perfect because we'd have one y left. 6 take away 5 is 1, so that means there's 1 root 5, and then we have one y left inside of the radical sign, okay? So our answer then would be 2x squared y. Then we've got the 5 here. We still have the 2 left over in the radical, and then remember we still had one y because we just took 5 out, so we had 1 left. So our answer then is 2x squared y times root 5 2y. So these are kind of like little puzzles, putting everything in the right spot. So as you do these, on the handout, I did give you the answers so you could check yourself right away. And so remember, this is just part 1 of 7.4. The second part is going to be on rationalizing denominators, so be sure you watch that one as well. All right, we'll see you at the Zoom meeting, and if you have any questions on this, please shout out to me somehow, okay? All right, take care.